Late December 1950 arrived across the Appalachian Mountains with the familiar weight of winter. Light snow fell from gray skies that hung low over the ridgelines, settling on coal towns tucked into narrow hollows and rail yards where crews moved through their routines without urgency. The air was cold but not severe, the snowfall steady but not remarkable. In places like Pineville, Kentucky, and Logan, West Virginia, smoke rose from chimneys in vertical columns, undisturbed by wind. The mountains absorbed the snow quietly. The geography of the region shaped everything. Long parallel ridges ran northeast to southwest, their slopes steep and forested. Between them, hollows carved by centuries of water carried creeks, roads, and rail lines toward larger valleys. Many communities occupied these narrow spaces, accessible by single roads that climbed switchbacks or followed creek beds. Rail corridors threaded through gaps in the ridges, connecting coal mines to distribution points farther west and north. In winter, this terrain required constant maintenance. Crews kept roads passable and rail switches clear. Supply trucks made scheduled runs. The system functioned because it had been built to function under these conditions. Isolation was not an emergency here, it was structural. Towns separated by a ridge might be 10 miles apart by road and 40 by rail. Telephone lines connected most places, but service depended on wooden poles strung along exposed ridges. Power came the same way. When conditions worsened, repair took time. Winter meant adjusting expectations, not abandoning them. December snow was anticipated. What came next was not. The snow continued into the final days of the year without pause or intensification. Accumulation was measured in inches per day, not feet per hour. There was no single moment of alarm, no sudden change in the weather that signaled danger. The sky remained gray. The snow kept falling, and the mountains, indifferent to human schedules, began to fill. The meteorological conditions responsible for the prolonged snowfall were not dramatic in structure, but devastating in persistence. A low-pressure system moved across the Tennessee Valley in late December and stalled against the southern Appalachians. Behind it, cold air from the north settled into the valleys east of the mountains, creating a dense layer that resisted displacement. Warmer, moisture-laden air from the Atlantic moved westward and rode up over this cold wedge, cooling as it ascended and releasing precipitation continuously along the ridges. This pattern, known as cold air damming, is common in the Appalachians but typically short-lived. In late 1950, it did not break. Low-pressure disturbances moved along the stalled front, each one reinforcing the cycle. Snow fell, paused briefly, then resumed. The system lacked the violent energy of a nor'easter or the compact intensity of a lake effect band. It simply persisted. Day after day, the same atmospheric configuration repeated itself, depositing snow across hundreds of miles of mountain terrain without variation or relief. Forecasting in 1950 relied on surface observations, radiosonde data from a limited number of stations, and hand-drawn weather maps. Meteorologists could identify the presence of the low-pressure system and the cold air mass, but predicting how long the pattern would persist was beyond the precision of available tools. Warnings were issued for heavy snow, but the word heavy conveyed intensity, not duration. Communities prepared for a storm, not for weeks of accumulation. The snow continued into the new year. By January 2, many locations had recorded more than 20 inches. By January 5, some areas exceeded 30. The snow fell evenly without the wind-driven drifting that characterizes blizzards. It built up in layers, compressing under its own weight. Roads disappeared beneath smooth white surfaces. Rail tracks sank into troughs. The mountains, covered uniformly from ridge to valley floor, took on a simplified geometry, their details erased by depth. The snow fell without theater. There were no gusts, no whiteout conditions, no moments of crisis that could be pointed to later as the turning point. Flakes descended in steady columns, visible against the gray sky, accumulating at a rate that seemed manageable hour by hour but became overwhelming when measured across days. The sound of the mountains changed. Voices carried less far. Machinery sounded muffled. Even creeks, still flowing beneath thickening ice, ran quieter. In the hollows, snow filled the space between ridges with an evenness that concealed the landscape beneath. Roads that followed creek beds became indistinguishable from the surrounding terrain. Fences disappeared. Small outbuildings became white mounds. The verticality of the mountains remained, but their texture was gone, replaced by smooth white slopes that reflected what little light filtered through the clouds. On the ridges, snow accumulated to depths that exceeded the height of a standing man. Trees bent under the weight. Some snapped. Most endured, their branches layered in white. Temperature records from the period show consistent cold, with daytime highs remaining below freezing across much of the region. Nighttime lows dropped into the single digits Fahrenheit. The cold prevented any melting, even on south-facing slopes during midday. Each day's snowfall added to the total without subtraction. By mid-January, verified reports from weather stations and coal company records documented snow depths exceeding 40 inches in the higher elevations of eastern Kentucky and southwestern West Virginia. Some isolated areas reported depths near 5 feet. The duration, not the intensity, defined the event. A heavy snowfall of 12 inches in 24 hours strains infrastructure but can be managed. 40 inches over 2 weeks, falling without interruption, exceeds the capacity of equipment designed for typical winter maintenance. Plows could not keep pace. Crews worked around the clock, clearing the same roads repeatedly, only to find them covered again within hours. The snow did not stop. The system did not move. And the mountains, patient and indifferent, continued to accumulate. Roads were the first system to fail, not from catastrophic blockage but from steady attrition. Snowplows operated continuously through the first days of January, clearing main routes and attempting to maintain access to isolated communities. But the equipment of the era had limitations. Plows were mounted on trucks or pulled by tractors, effective in moderate snow but overwhelmed by continuous accumulation at depths beyond 2 feet. Blades pushed snow to the sides of the road, where it compacted into walls that narrowed the passable width with each pass. Eventually, the walls met. The road became a trench, then disappeared entirely. Secondary roads, those serving smaller towns and coal camps deep in the hollows, were abandoned first. Plowing priorities shifted to main corridors and routes serving critical infrastructure. Even these efforts faltered. In Pineville, Kentucky, crews reported being unable to clear roads faster than snow refilled them. In Logan County, West Virginia, a state highway remained impassable for more than a week despite continuous clearing attempts. Trucks carrying coal, food, and mail could not reach their destinations. Drivers who attempted to travel found themselves stranded, their vehicles buried in drifts that had formed not from wind but from sheer depth. Rail operations, more resilient than road transport, faced different challenges. Snow accumulated on tracks and around switches, freezing into place under the weight of subsequent layers. Crews used steam to melt ice and shovels to clear drifts, but the work was slow. Locomotives could push through moderate snow depth, but deep accumulation required rotary plows, specialized equipment not universally available on the region's rail lines. Where plows operated, they cleared corridors temporarily, but switches remained vulnerable. A single frozen switch could halt an entire line. By the second week of January, coal shipments from the region had dropped significantly. Mines continued operating where possible, but railcars sat immobile on snow-covered sidings. The Baltimore and Ohio Railroad reported severe delays across its West Virginia lines. The Louisville and Nashville Railroad suspended service on several mountain routes. Towns dependent on rail delivery for food, heating oil, and supplies began to ration. Communication with the outside remained limited to telephone lines that still functioned, but even these were failing. The mountains had not been cut off by a single event. They had been gradually buried, and the systems that connected them had stopped working, section by section, until isolation became complete. Ice came with the snow, not in a single freezing rain event but as a continuous process. Moisture in the air condensed on power lines, utility poles, and telephone wires, freezing into layers that accumulated over days. Snow adhered to the ice, adding weight. The lines, strung along exposed ridges where wind was typically a concern, now faced a different stress. Wooden poles, many decades old, bent under the load. Crossarms sagged. Wires stretched, then snapped. Power outages began in isolated pockets and spread. A single line failure in a mountainous area could disconnect an entire community. Crews dispatched to repair damage found roads impassable in conditions that made work dangerous. Climbing poles in deep snow and sub-freezing temperatures required time and caution. Replacement materials had to be transported to sites that were no longer accessible by vehicle. In many cases, repairs were deferred until conditions improved. The outages lengthened from hours to days, then weeks. In coal towns dependent on electricity for mine operations, lighting and heating systems beyond coal stoves, the failures cascaded. Machinery stopped. Water pumps froze. Homes went dark. The sensory environment of these places changed. At night, the absence of electric light rendered the snow a uniform gray under cloud cover. During the day, the silence was pervasive. No machinery hum, no distant rail whistles, no evidence of the industrial rhythm that typically defined these communities. Only the muffled sound of shovels scraping compacted snow, and the occasional crack of a tree branch breaking under weight. Telephone lines failed in parallel with power. The same ice loading and pole failures that disrupted electricity severed communication. Towns that had maintained contact with regional centers found themselves cut off. Emergency calls could not be placed. Coordination of relief efforts became dependent on runners or messengers traveling on foot or by snowshoe, a reversion to methods that predated the infrastructure now lying broken under the snow. The failures were not uniform. Some areas retained power and telephone service throughout, their lines protected by terrain or fortune. But across the central and southern Appalachians, the pattern was consistent. Infrastructure designed for typical winter conditions could not withstand prolonged loading from ice and snow. The mountains, already isolated by geography, became unreachable by the systems that had made them part of a larger network. What remained was endurance without external support. Clearing operations continued under conditions that resisted progress. Temperatures remained below freezing, preventing any natural melting. Snow that had fallen days earlier had compressed into layers dense enough to resist plows. Crews working to reopen roads found that each pass produced marginal improvement. Snow was pushed aside, but the depth of accumulation meant that cleared surfaces remained above grade, creating narrow channels rather than passable roads. In places, the snow was too deep for plows to function effectively. Crews resorted to shoveling by hand, a process measured in feet per hour rather than miles per day. Rail clearing followed a similar pattern. Rotary plows, where available, cut through drifts but required locomotives to push them, consuming fuel and time. Switches, buried and frozen, had to be individually cleared and thawed before trains could move. On lines where traffic had been suspended, snow had settled and compacted, turning tracks into shallow depressions within larger white fields. Reopening these corridors required multiple passes, crews stationed at intervals, and constant vigilance against reaccumulation. Priority was given to coal lines, but even these took days to restore to partial operation. The work was exhausting. Men operated in shifts that extended beyond the limits of safety, driven by the knowledge that isolated communities depended on access. Engines strained in the cold, requiring frequent maintenance. Fuel supplies, already constrained by transportation failures, were consumed at elevated rates. Equipment broke down under continuous use. Repairs were made in the field in sub-zero temperatures with limited tools. Progress was incremental. A mile of road cleared one day might require re-clearing the next. A rail line open to limited traffic might close again if a single switch failed. In towns cut off from resupply, rationing became standard. Coal stockpiles, typically sufficient for weeks, ran low as heating demands increased and deliveries ceased. Food supplies dwindled. Medical emergencies could not be addressed with outside assistance. Communities relied on internal resources and networks of mutual support that predated modern infrastructure. Those with access to stored goods shared. Those with medical training treated injuries and illness without hospital access. The social fabric of these places, built over generations in isolated terrain, became the primary mechanism of survival. Time was the only force working toward resolution. The snow could not fall forever. The cold would moderate. But in mid-January 1950, across the snowbound mountains, there was no indication of when that change would come. There was only the work, repeated daily, and the slow, grinding effort to maintain connection in a landscape that had, for the moment, closed. Change came gradually. By late January, the low-pressure system that had stalled over the region finally shifted eastward. Cold air damming weakened. Temperatures rose, not dramatically, but enough to cross the freezing threshold during daylight hours. The snow stopped falling. What remained began to settle, compacting under its own weight, its surface transitioning from powder to crust. Meltwater appeared in thin streams on south-facing slopes, refreezing at night into ice layers but resuming flow each day. The landscape revealed itself in stages. Ridges emerged first, their crests bare where wind had scoured the snow or where exposure to sun accelerated melting. Valleys took longer, their snow depths measured in feet rather than inches, their drainage slowed by frozen ground beneath the snowpack. Roads remained carved into deep banks of compacted snow, their surfaces navigable but constricted. Rail lines reopened in sections, prioritized by economic necessity. Coal shipments resumed, though at reduced volume. Supply trucks reached towns that had been isolated for weeks. The economic impact was documented through coal production records, freight tonnage reports, and municipal accounts. Coal output from the central Appalachian fields dropped by an estimated 30% during the first 3 weeks of January. Rail delays cascaded through the national coal distribution network, affecting power generation and industrial operations far beyond the region. Local economies suffered immediate losses from halted commerce and delayed wages. Some businesses did not recover. Some families, already operating at the margin, faced debts that took years to repay. Infrastructure damage was assessed as access returned. Power line repairs continued through February. Telephone service was restored in stages, with some remote areas remaining disconnected for weeks. Roads required grading and repair beyond simple snow removal, their surfaces damaged by freeze-thaw cycles and the weight of clearing equipment. The costs, borne by state highway departments, utility companies, and railroads, ran into millions of dollars, significant figures in 1950 terms. The event prompted reassessment. State and local governments expanded winter maintenance budgets and invested in heavier equipment capable of handling deeper snow. Utility companies began programs to reinforce poles and lines in vulnerable areas, though full implementation took years. Coal companies, dependent on reliable winter transportation, pushed for improved rail infrastructure and backup supply routes. The changes were incremental, shaped by limited budgets and competing priorities, but they reflected a recognition that the region's infrastructure had been tested beyond its design limits. The mountains reopened. By early February, most roads were passable, most rail lines operational, most towns reconnected to the networks that sustained them. Snow remained, piled in gray banks along roadsides and compressed into hard layers in shadowed hollows, but its presence no longer dictated movement. The crisis, if it could be called that, had passed without drama, resolved not by intervention but by time and persistent effort. What remained was memory and consequence. The winter of 1950 entered regional history not as a singular catastrophic event, but as a prolonged test of systems and communities. The snow itself was eventually forgotten in its specifics, but the reality it revealed, that isolation in the mountains was a permanent condition, managed but never eliminated, persisted. The infrastructure built to overcome geography could fail. When it did, the mountains returned to what they had always been: barriers, indifferent and impassable, shaped by forces that did not acknowledge human schedules or needs.